Imagine a universe where everything you know from the chair you're sitting on to the stars in the sky is made up of tiny, vibrating strings. Sounds like science fiction, right? Well, this is the concept of string theory, one of the most fascinating and mind-bending ideas in modern physics. Today, we're diving into how string theory suggests the existence of extra dimensions beyond the ones we experience. Buckle up for a journey that might just change the way you look at reality. To understand string theory, we first need to revisit what we know about particles. In the standard model of physics, everything is made up of tiny particles, like atoms, electrons, and quarks. But string theory takes this idea one step further, proposing that these particles aren't just points in space, but rather vibrating strings of energy. These strings are incredibly small, much smaller than the particles we can currently detect, and depending on how they vibrate, they can create different particles, like electrons or quarks. This simple idea could be the key to understanding all of the fundamental forces of nature. But here's where things get wild. In string theory, our universe doesn't just have the three dimensions of space and one of time that we experience daily. Oh no, it suggests that there are extra dimensions beyond what we can see. In fact, string theory proposes that there could be as many as 10 or 11 total dimensions. These dimensions are tiny and compacted, so small that we can't perceive them with our senses. But they could be lurking in the fabric of the universe, hidden away in a way that affects everything from gravity to the very particles that make up matter. So, why should we care about these extra dimensions? Well, these hidden dimensions could help solve some of the biggest mysteries in physics. For example, gravity, the force that pulls objects toward each other, is much weaker than the other forces in nature, like electromagnetism. String theory suggests that gravity might be spreading out across these extra dimensions, which is why it feels weaker on the large scale of the universe. By understanding how gravity interacts with these extra dimensions, we could unlock new insights into how gravity works, and maybe even bridge the gap between general relativity, which explains large-scale phenomena, and quantum mechanics, which explains the tiny world of atoms. Now, don't get too excited just yet. String theory is still a work in progress. One of the biggest challenges scientists face is proving the existence of extra dimensions. Since they're so small, we don't have the tools to directly detect them. To test string theory, scientists are looking at ways to detect the effects of these hidden dimensions. This could involve high-energy experiments, like those conducted at particle accelerators, or even the detection of gravitational waves that might carry information about these extra dimensions. While string theory may seem like a far-off concept, it's changing the way scientists think about the very building blocks of the universe. With more research and new technologies on the horizon, we could one day uncover the truth behind the mysteries of the extra dimensions and the very fabric of reality itself. Thanks for joining me on this wild ride through the world of string theory and extra dimensions. If you're as fascinated as I am by the mysteries of the universe, be sure to hit that subscribe button for more videos that explore the science that shapes our reality. Until next time, keep asking questions and stay curious.